phenomena which we humans cannot control. It occurs spontaneously, right? So basically, any naturally occurring phenomena or the physical process is called a natural phenomena, right? Okay. So there are so many destructive phenomena in our surrounding. Can you name some of the destructive phenomena in our surrounding?
Say earthquakes,
Hmm?
landslides,
Landslides,
tsunamis,
tsunamis,
and cyclones.
cyclones. Very good. Okay, in the figure you can see these are all natural phenomena which we don't have control over, like flood, earthquakes, drought, hurricanes, landslides, right? Thunderstorm, wildfires, tsunamis, volcanoes. These phenomena cannot be controlled. But what can be done? That humans can minimize the damage done to the property and life by taking precautionary measures, right? So suppose what are the precautionary measures we need to take to stop desertification of agricultural lands?
Say
One more question? What are the methods we need to adopt to reduce the extreme heat? Salmon has
say
joined.
by planting more trees
Yeah, by planting more trees. Yes.
and by reducing the factory uh, wastes that
Reducing the
pollutes the
factory
air.
waste. Okay, that has an indirect effect on desertification. Yes. Okay. Yes, Ahmed. Assalamu alaikum.
Walaikum Assalam, sir.
Okay. So Ahmed, today we are beginning with the new chapter. Okay, that is now some natural phenomena, right?
Okay.
So we have just begun. So you see, natural phenomena are those phenomena which are not under human control. Okay, they occur
Yes, sir.
naturally. Okay, they could be naturally occurring calamity. For example, this drought, earthquake, volcanic eruptions, floods, tsunamis, hurricanes, right? A wildlife fire. These are all examples of natural phenomena, right? And they does great damage to human life and property. Okay, so you guys tell me that we people, most of the, not most of the, but a big portion of human population resides in urban areas. Okay, so urban areas, the vegetation cover is very less, right?
Yes, yes.
And in the previous class, I told you there's a concept called urban heat island that is found in urban areas, in cities, in big metropolitan cities, right? So in urban heat islands, we saw that since there is no open soil or open vegetation, most of the heats falling on the buildings, on the concrete pavements, gets reflected back into the atmosphere, right, guys? So due to this, what happens? The heat over the urban areas rises, and it leads to formation of urban heat island, right? So what measures we need to take to reduce this, reduce the heat?
So by doing afforestation.
Afforestation has to be can be done in areas where there is availability of land, no? But in cities, open areas are rare to found, right?
Yes, sir.
So we can do terrace farming. Have you heard of this terrace farming?
Yes, sir.
Yeah.
Yes, sir.
So people do terrace farming, right? And in streets, in the streets, we can plant so many different types of trees. Okay,
Yes.
we should promote building of parks in colonies, right? We ourselves should practice gardening. So if every citizen living in urban areas at their personal level contribute in this, then we can reduce the impact of urban heat island. Okay. Also, the use of air conditioners should be discouraged, right? Because the the heat emitted from air conditioners, if you ever pass by the exhaust air coming from the air conditioner, okay, it is very uncomfortable. You will then notice that how much of heat is being emitted into the atmosphere, right? So air
Yes, sir.
conditioners also have a great role in increasing the overall heat, right, guys? Okay. So in the chapter, the two main natural phenomena that does great damage to human life and property. First one is the light, and then next one is the earthquake, right? For example, you guys tell me which country was recently affected by earthquake and almost lakhs of people died there.
The
Sir,
Turkey and
yes, Turkey.
Turkey and some parts of Syria as well,
Yes,
right?
sir. Yes,
Okay. So first thing is lightning. Okay. So lightning, we see it is basically an electric discharge or electric spark that occurs in nature on a major scale. Okay. So when two clouds carrying charges collide, then there's a production of a spark that we see as light, right? It can be very deadly. Okay. So if someone comes in contact with this lightning, okay, or any building or any tree comes in contact with the lightning, the person most likely will die, or the building or the tree will will catch fire. Okay, that's why you will see that earth rods are attached on top of buildings. Okay, earthing rods are attached so that if this lightning falls over it, it will go via this earthing rod into the ground, and hence the effect will be neutralized and building will not collapse or catch fire. So we will discuss
excuse
that
me,
in
sir.
detail. Yes.
Why do lightnings fall on trees
Why do lightning
mostly?
falls on trees? Look, see this here. See the lightnings here. Mostly they fall on trees because they look for taller objects. Okay. Suppose you are standing in a field. Suppose someone is standing on a field. Okay. And there are two trees. One is a lengthier tree and one is a shorter tree. Most likely the lightning will fall in the taller tree. Why? What happens here? Because the charge this lightning carries, it has to be conducted into the earth. Okay, it has to be conducted into the earth. It needs to go into the earth. So it looks for the shortest path. So the long tree will provide the shortest path, right, guys?
yes, sir.
Got this, Arhan?
Yes, sir.
Okay, so it has to do with the shortest path. Okay, now let's talk about the history of the charges. Okay, the discovery of charges is almost 2500 years old, right, guys?
Yes,
So
sir.
see here, the Greeks were already aware of the electric charges from 600 BC. Okay, BC means before Christ.
Photo crisis, yes, sir.
Before Christ. Okay, so before Christ, so when Christ was born, before the birth of Christ, almost 600 years back, the Greeks were already aware of the charges, of the electric charges. So they knew of a substance called amber, a type of resin or synthetic polymer. Okay, so they knew about a type of synthetic polymer that was amber. Okay, so when it was rubbed together with a fur, they observed that the amber can attract objects like hair, right? So when they used to rub this amber, which was a synthetic polymer, with fur, they observed that uh, the amber has gained some charges and it can attract light. Okay, so the history of charges dates back as old as 600 BC. Okay, so if you calculate from now, so right now it's 2023. Okay, so you add, we are currently in AD, after Domini, or we are living in Common Era, also called as CE, right, guys? So if you were to calculate how long when it was discovered, so you will simply add the two dates here. Add the two dates here. So almost 2,623 years ago, the charges were developed discovered by Greeks. Specifically, there was a scientist named Thales. Someone asked you the name of the scientist. Remember, what was the Who was the scientist? Thales. All right. Okay. Now, later in the year 1752, Benjamin Franklin was an American scientist who discovered and proved that lightning and spark produced from the clothes are all same things. So in the winter season, when you take out your clothes, when someone is taking out the sweaters from his body or the clothes from his body, he might you will observe some sounds being produced. Have you guys observed that?
Yes, sir.
Yes, Ahmed.
Yes, sir. Can you repeat?
In the winters, okay, in the winters, when you are removing sweaters from your body, clothes from your body, you will see that there's some sound is produced. Have you observed that?
No, sir. Not really.
Look,
I
the sound is very similar when the two live wires are touched. When two live wires are touched, so you must have heard the sound produced when two live wires are touched. So the sound coming from the removing of clothes from our body is similar to that sound. Okay.
Oh,
In
yes, I have.
fact, the spark produced when two live wires are touched, or when we take out clothes or rub two clothes against each other, or the spark produced in the lightning, all of them are same. There's nothing different in them.
Oh,
Okay. There might be a difference in their strength, but all of them are produced in the same manner. Okay, all of them are charges.
yes,
So the
sir.
question comes here, what are the charges? First question comes, what are charges? So if you see any atom is made up of what? Subatomic particles.
Yes, sir.
So atoms, we know they are made up of proton, electron, and there's one more. What do we call that?
And neutron.
Neutron.
Neutron. Good. Okay. So charge has to do only with proton and electron. Why? Because neutron has got zero charges in it. Okay, so when we talk about charges, we specifically talk about proton and electron. So proton is a positive charge subatomic particle, while electron is a negative charge subatomic particle. All right. So see this here. This proton and proton and neutron are found in the nucleus of any atom, while electron revolves around this nucleus. Getting it? Look, this is your proton and this is your neutron. P for proton and for neutron. Okay. And around this electron will be revolving, having negative charge. So this is basically the structure of a typical atom. All right, guys. Okay. So
Yes, sir.
the thing is, naturally, the atoms which we see are electrically neutral. So there's two things, two concepts here. Okay. When I say electrically neutral, what does it mean? Okay. Take example of a sodium atom. Take example of a sodium atom. Na, that is sodium. By the way, you guys tell me about the properties of sodium. It has got some special properties.
Sir, sodium reacts with water very unpleasantly.
Yeah, very explosively. And one more property about it, you can literally cut it with a knife.
Huh?
Okay.
Yes,
It,
sir.
it can,
It's like a
yeah, it looks like a clay. Okay. Have you ever seen a potter using clay? Okay. So it looks almost similar to clay in its appearance. Okay. Although it looks in texture, it is similar to, not in texture, in color, it is similar to aluminum or silver. Anyway, so I was talking about sodium. Okay. So do tell me, have you guys studied about atomic numbers yet?
No, sir.
no, sir, not yet.
Not yet. Okay. So the sodium, let's say, okay. So on the periodic table, it lies on hydrogen, helium, lithium, thallium. All right, lies on 11 when you will study about periodic table. Anyways, so if you see the atom of a sodium in nature, the number of protons and electrons in it is same. The number of proton and neutron in it is same. Okay, but sorry, not proton, not neutron. We are actually talking about electron here. Since there are no charges over neutron. So the number of protons and electrons, naturally it is same. Okay, but due to some disturbances, if the balance is disturbed, if suppose the number of proton or the number of electron becomes larger, becomes greater, then then this atom is said to have acquired some charges.
Yes.
Got this?
Yes, sir.
Okay.
Yes, sir.
So this sodium can either become positive if it has an excess of proton, if it has excess of proton, or this sodium can become negative if it has excess of neutron. So what do I mean by it? See here. Say this is your sodium atom. Okay. This is not the atom looks like, just for purpose of understanding we are considering it. So let's say earlier it had 1, 2, 3, 4 and 5 proton. Okay. So and earlier it had also 5 electron. All right, guys. But if I were to make some changes in it due to some external disturbances, the number of proton became 6. Okay. So which one is greater here? Whose number is greater, proton or electron?
Sir, proton.
Proton. So the sodium atom is said to have acquired positive charge here. All right. Okay. Or if I were to increase the number of electrons here, okay, the number of proton is same. I were to increase the number of electrons. Now electron is 6 here. The proton is 5. So the atom is said to be negative or positive.
Sir, positive.
No, I
Sir,
have
negative.
increased one electron. No? Electron is negative charges. So the atom
Sir,
will
it will be
have a
negative.
negative charge. Yeah, it will be negative.
Okay.
So that leads to the formation of charges. Whenever an atom gains some charges, it is said to have acquired. Whenever the balance of proton and electron is disturbed, then the atom is said to have acquired charges. Okay, it might be positive, it might be negative. Okay. We know that every atom comprises of subatomic particles. What are they? Electrons, protons, and neutrons. Okay. And all these particles share a common property that they carry charges. Right. So electrons, protons carry charges while neutron does not carry charges. It has 0 charges in it. Right. And in the nucleus, which two subatomic particles are found? Proton and
Sir,
neutron.
proton and electron.
Okay. And which one rotates around the nucleus?
Um,
Say
you-
electron.
Electron. All right. Okay. Now, electrons have a negative charge, you know that, while protons have a positive charge. And we know that atoms carry a balanced charge. However, these charges may sometimes become out of order, as we discussed earlier. So, why they become out of order? For example, you take a glass rod, and you take a piece of cotton. And if you were to rub them, then the glass rod will acquire positive charge and the cloth will acquire negative charge. Right. Now the question comes, why it happens so? So it's naturally okay. It naturally happens. Right. So there are so many things which we don't have answer for. Right. So it's a natural convention that whenever you will take a piece of glass rod, okay, in laboratories you might see a piece of glass rod. Okay. Or basically the glass rod is used to stir solutions. If you're mixing two solutions, you basically use a piece of glass rod. Okay. So a glass rod when rubbed with a piece of cotton cloth or any another cloth, the glass rod acquires positive charge and the cloth acquires negative charge. So there what is happening? The charges are becoming out of order. Hence they acquire different charges. Okay. See the first figure, second and third figure. What do you guys observe here?
um, sir,
Count the number of yellow and pink dots in the first one.
okay, sir.
So in the first one, the number of proton and electrons are same.
Yes, sir.
Protons and electrons are same. That is, both of them are 5. In the next one, what has happened?
Sir, the
So the number of protons.
Look, I am telling you, yellow one is no electron.
yes, sir.
Okay, now it will be easier. Pink one is proton. Now to tell me.
Sir, the protons
So,
are less than the electrons.
Yeah.
Yeah, the value of them are less of.
So the given atom acquires negative charge here. Okay. So it has become negatively charged. Okay. And see the third one.
Sir, the electrons are now less because of the positively charged, and the
Yes.
proton have increased.
Yes. Okay. So that's a positively charged atom, right, guys? So here the number of proton you see, it is how much? It is 3, while the number of electron is how much?
Five.
It's 5. Okay. Hence there's a difference of 2 here. Okay, so which one is greater? Clearly electron is greater. Hence the charge on the body is -1. And here the overall number of proton is greater. So it's a positive charge. So now we know that what is a charge object in which there is unbalance of proton and electron. And what is an electrically neutral object where number of proton and electrons are same. Right?
So, yes, sir.
Yeah. Now, further, if you see, just like that, unlike poles of magnets attract each other, similar to that, the unlike charges, like a positive or negative charges, will attract, while the like charges, meaning if both of them have same dipole, meaning same charges, positive, positive, or negative, negative, then they will repel each other. Right.
Yes.
So what is the property? That like charges repel while unlike charges attract. Right, guys?
Yes, sir.
Okay. Okay, now moving on, let's talk about how charges are transferred from one body to another. Okay. Before that, there was an activity in your NCERT textbook. I have taken that. See activity 12.3. Okay. Can you guys see it properly? Okay.
Yes, sir.
So One of you read the activity. Ahmed, you read the activity.
Okay, sir. Inflate two balloons, hang them in such a way that they do not touch each other. Rub both the balloons with a woolen cloth and release them. What do you observe? Now let us repeat this activity with the used pen refills. Rub the refill with the polythene, place it carefully in the glass tumbler using the tumbler as a stand. Rub the other refill also with polythene, bring it close to the charged refill. Be careful not to touch the charged end with your hand. Is there any effect on the refill in the tumbler? Do the two attract each other or repel each other? In this activity, we have brought close together. We charge the objects that were made of the same material. What happens if two charged objects made of different materials are brought close to each other? Let's find out. Rub a glass, rub a refill and place it gently in a glass tumbler. As before, bring an inflated charged balloon near the refill and observe.
Okay. So
Uh,
what do you guys observe here in the first one? In figure 12.1, you see both the objects are made up of same material. Okay. And both has been rubbed with a woolen cloth. Right, guys?
yes, sir.
So do tell me if will the two objects acquire same charges or different charges? Notice
Different.
different charges. Notice one thing here. The two objects are made up of same material, that is rubber, right?
Yes.
Both the objects, that is balloons, are rubbed by a woolen cloth. Okay. So the thing is here that since the two materials are same and they have been rubbed with the same material, naturally they will acquire the same charges, right? So
Yes, sir.
this balloon here, when it is rubbed with a piece of woolen cloth, okay, both the balloons materials are same and they are rubbed with the piece of woolen cloth, hence they will acquire same charges. Hence in the activity you will see later on when they were charged, they have started to repel each other. So this proves the interaction between the charges, that unlike charges repel each other. So the two balloons might have gained positive charges or might have gained negative charges, right?
Yes, sir.
Okay. So in fact, if you see the objects, the two balloons acquire positive charges. All right. And see the next one. Next one, the figure 12.2. Here what we have done, we have repeated this activity with used pen refills. So take used pen refills. Okay. Rub one refill with polythene and we have placed it in the glass tumbler. Okay. Now
Yes, sir.
what we have done then, we have rubbed the other refill also with the polythene and we are trying to bring it close to the charge refill. Okay. Now we have to be careful not to touch the charge in with our hand. What will happen if we were to see you are taking this refill? Okay, this is its nib. So you have charged this part. Okay, so you should not touch this part, because if you will touch this part, the charge will transfer to your body. Okay, that's why it says to be careful when you are bringing it close to the charge refill, right? So what do we observe here? Do they repel or attract? In this case also they will attract each other, because both the refills are of same material, that is of plastic here, and both of them have been rubbed with the polythene, right, guys? So in this one also the interaction is happening between like charges. Are you guys getting it or not?
Yes, sir.
Arhan? Yeah. So you guys explain to me what happened in the figure 12.3. Why the two objects are attracted in this one? The previous two objects were repelling. Why this one is attracting?
Because of electron and proton, sir.
because the two materials are different here.
Yes, sir.
And have they been charged? Have they been charged? Have they been rubbed with the same material or different?
Same.
Sir, same.
Same material. We have rubbed both of them with same material, but the two materials are different. That one is made of rubber, one is made up of plastic here. So here, the two objects have acquired unlike charges, hence they are attracting each other. Right, guys?
Yes, sir.
So we summarize our observation as follows: a charged balloon repelled a charged balloon. A charged refill repelled a charged refill. Okay. Okay. Figure 12.2. Here, repulsion was happening, not attraction. All right, guys. And a charged balloon attracted a charge refill here. Okay. Okay. Now let's move ahead. See, the balloon we were talking about, it would have acquired negative charge. Okay, and the woolen sweater was actually acquiring positive charge. Right, guys? So charging can be done by rubbing. Charging can be done by bringing two objects closer, or charging can be done by touching two objects. So what I'm meaning basically here, see here, how transfer of charges takes place. Let's talk about that. Okay. So if you have got, see this figure here, just observe this figure and it will get clear to you. See the first atom and the second atom. Okay, it has got how many electrons? There are 3 electrons in it. And there are how many electrons in this one? 4 electrons. Okay. Now in the next, in further what happened? The transfer of electron is taking place from one atom to another. All right. That is how objects acquire charge now. See this one as well. The balloon must have gained negative charges from this woolen sweater now, because initially it was neutral. The number of proton and electron in it was same. It must have gained some of the electron from this woolen sweater upon rubbing.
Yes, sir.
That's why it has excess amount of electron. So same thing happens here. The two electrons, the two atoms must have been rubbed. Okay. Or either might have been rubbed, or they might have been touched together or brought somewhat close to each other. Okay. So see what happened here. The electron has been transferred to the first atom. How many electrons are now in this one? There are 4 electrons. And there's a deficiency of 1 electron in this one. Right. So earlier, this object was having a positive and this one was having a negative charge. Now, after the transfer of electron, this one has become a negative body, while this one has become a positively charged body. Right, guys? Okay. Further, if you guys see, charges can transfer from one charged body to a body which is not charged, which is neutral. What I'm trying to say, that say you have a charged body, you know that this body is carrying charge. So you can transfer the charge from transfer the charge from that body to an electrically neutral body. Okay, getting it?
Yes, sir.
Or charge can also transfer between two charged bodies as well. See, we know charge transfers due to the movement of the electron from one atom to another. So one question I'm posing to you guys, why we are talking about movement of electron here only? Why not proton?
So since electrons revolves around the protons, so
Revolves around the nucleus. Be specific. Revolves around the nucleus. Yeah. So proton and neutron, Ahmed, you see, they are in the nucleus. They are fixed, while electrons have the freedom to revolve around it. So that's why it can transfer from one atom to another. All right.
Okay, sir.
Okay. So as I was saying that charge can transfer from an electrically charged body to a neutral body. Okay, a body that has not having any charge, and charge can in fact transfer, the transfer of charges can take place between two electrically charged body as well. Two electrically charged body as well. E stands for electrically. Okay, so suppose a body is having a positive charge and a body is having negative charge. Okay, say it has, let's say it has five excess electrons. Okay, it is having a -5 charge, and it is having a minus 3 sorry +3 charge. Okay, so charge will also transfer from a body having higher charge to a body having lower charge. So in this case transfer of charge will take place from here to here. It is having -5 charge, it is having +3 charge. So the transfer of charge will take place from here to here, right?
Yes, sir.
Since the body is having excess amount of charge, it is having a deficient amount of charge, right?
Yes,
Okay, so also when I say that the body is having body is having 5 electrons, meaning that 5 electrons are rotating around the nucleus. If 5 extra electrons are rotating around the nucleus, and the body is
excuse me, sir.
having. Yes, Arhan.
Infinite amount of electrons can rotate around the nucleus for certain amount.
Yes.
Is there a limit on which how many electrons can rotate around the nucleus?
Yes. Look, you see, for different elements, the number of electrons revolving around the nucleus is different. Okay. And it's not like it rotates around the nucleus in random. When you will see further, this is the nucleus. These are the orbits in which the electrons revolve. So in class 9, you will get to know in the first orbit, only 2 electrons can revolve. In the second, only maximum 8 electrons can revolve. Then the series goes like this: 2, 8, 14, like this. Okay, so in discrete orbits, in specified orbits, electrons revolve, and the number of electrons that will revolve in each orbit is fixed. Okay, the maximum number is fixed. Okay.
Okay.
So whenever we are talking about this extra electron, this extra electron is actually, it goes to the outermost orbit, right?
Sir.
So we will discuss that in future classes in detail. Okay. As of now, just know that when I say this body is having a -5 charge, it means it has got 5 extra electron in it, and this body has lose 3 electrons, hence it is having +3 charges. Okay, because the body cannot lose protons since it is in the nucleus. It has actually lose 3 electrons. Okay, what do I mean? Suppose it was earlier having 10 protons and 10 electrons as well. All right, now the body lose 3 electrons out of it, so the number of proton is 10 and the number of electron is reduced to 7 only. So what is the net effective charge on the body? Which one is greater? Proton, definitely. The body has 10 proton and it lose 3 electron. Now it has got only 7 electron. So the net difference of proton is greater here. Are you guys getting or not?
Yes, sir.
Ahmed, you? All right. So we say the difference here is 3. So proton is having 3 more charges here. Okay. Now, as I told you, the charge can the transfer of charge can take place from electrically charged body to a neutral body, and from an electrically charged body to another electrically charged body as well. Okay. Now let's study about the method by which transfer of the charges takes place. So first one is the conduction, another one is the induction. Basically, in conduction, what happens when a charged object will come in contact with a conductor, it results in the transfer of charges to the conductor. Suppose someone touches a live wire, okay, or someone touches an object which is having electricity or current in it. So the object is in direct contact with the electrically charged object, right? So in that case, the mode of transfer of charge is happening due to the contact between the two objects, and that is called conduction, right? See this one here. This is a neutral object here. Now I have brought a negatively charged rod. Is it in contact with the neutral object or not? Okay, you guys tell me, what did we observe here when I brought a negatively charged rod in contact with this electrically neutral object? So earlier it was neutral, but now it has 3 negative charges in it, and now further more charges were transferred in it, and now it has got how many? 5 electrons in it. That is -5 charge, -5. So the body has now become charged. So this is called charging by conduction. When we bring a charged object to a neutral object, okay, when we bring them in contact, the transfer of charge takes place. Okay, right. And one more
Yes,
thing,
sir.
apart from neutral objects also, if you were to bring a let's say it had only 2 charges here. It was not neutral initially. If you were to take another object which was not neutral initially, it was let's say negative, or let's say it was positive, then in that case also charge would have transferred to this body. Okay, so conduction can take place between an electrically charged object and neutral object, as well as between two charged objects as well. Hope you guys got this one.
Yes, sir.
Yes, sir.
So between two charged bodies plus between a charged and neutral body. Now next method of transfer of charge is by induction. Suppose you bring a charged object just close to a neutral object. You are not touching it. You are not touching the charged object to the neutral object. You just bring it close to the neutral object. That can also result in the what? That will not that will basically change the orientation of charges in that object. Yes, Arhan?
Sir, will it attract?
No, it will not specifically attract, but what will happen? The orientation of charges in the body will change. See this figure here. See this figure here. This figure actually was like this. We brought the negatively charged rod close to this body. All right. We are discussing induction. All right, guys. So the arrangement of proton and electron, initially it was like this. See, this is the arrangement. Okay. And one more thing, we have actually drawn it too close to it. Yeah. See, this was a body in which the arrangement of electrons and protons are shown here. Now, when we brought a negatively charged rod close to it, remember we are not touching it. See, the body is negatively charged here, and see, all the positive charges has shifted here. The arrangement of positive charges in that body has shifted towards this negatively charged rod, right guys? So induction, what happens when we bring a charged object to a neutral object? See that this is a neutral object now. Why is it
Yes,
neutral?
since it contains equal amount of protons and electrons.
Very good. Okay. So the body has gained charge or not? Has the body gained charge?
No, sir.
Ahmed, has the body gained charge? Ahmed, are you there? So we
Yes,
see
sir.
now
Yes, sir.
that the body has not gained charge, but the arrangement of charges has shifted. In this case, the positive charges has shifted towards the negatively charged rod. Okay, so that
sir.
is induction. That when a charged object is brought near a neutral object, it results in shifting in the position of the electrons in the other object. Okay, you see the electrons has shifted towards this side, right guys? That is the
Yes.
induction. Okay, now further there's a concept, there's an apparatus. Okay, in your NCERT book also you will find this one, that we can test the nature of objects, whether it is positively charged or negatively charged, or even or in fact if the object is charged or not, by using an electroscope. That is a very simple setup. Okay, one can make this setup at home if he has required materials. So that is simply a glass container here. Okay, and see the structure is like this. There's a metal plate placed over it, and there's a cork here. Okay, and a brass. This structure is made up of brass. Okay, so this is a metal plate. Okay, and it has been placed in it in such a manner that two gold foil leaves are attached to its end. Attached to its end. So gold foil leaves are what? They are extremely thin plates of gold. Okay, and they have been attached to this metal plate via this brass strip. All right, guys. And the container have been sealed by this cork. We have not taken a conductor here. Remember, this cork acts as a insulator. Okay, so I have got an animation for you guys to give you a better clarity of how this electroscope works. Okay, would you guys like to see that? Okay, see, that's a 3-minute video. Carefully see this one, the animation, how it works. Okay, do tell me if the voice is audible or not.
Gold leaf electroscope. Gold leaf electroscope is an instrument that is used for detecting the presence of electric charge.
Yeah.
Gold leaf electroscope. Gold leaf electroscope is an instrument that is used for detecting the presence of electric charge and its polarity. The instrument is also used for measuring the potential difference. The important part of the gold leaf electroscope are shown in the picture. The two extremely thin gold leaves are attached to the lower end of the brass rod fitted in a glass jar through an insulating cork of rubber. A circular metal disc is fixed to the upper end of the brass rod. The gold leaves are extremely thin conducting foils that have low mass per unit area and are flexible, so they respond very quickly to small electrostatic forces. Charging an electroscope by conduction. Let us see how an electroscope is charged by conduction. Charging by conduction involves the contact of a charged object to a neutral object. Here we can see a glass rod and a silk cloth. Now, when a glass rod is rubbed with a silk cloth, then the glass rod becomes positively charged. Touch the positively charged glass rod with the metallic disc. What do you observe?
Okay. So far, we see that the setup of electroscope is such that we have taken two gold leaf strips here. Okay.
Yes.
So the reason why we have taken gold leaf strips here is that they are very good conductor of electricity. Okay. And the two gold leaf strips here, they can do movement here. They are not attached to each other. All right. So they are just left hanging there. Okay. So when I have brought a positively charged glass set in contact with this metal strip here, this metal cap, notice the two have expanded here. The two are repelling each other. Why is it so, Arhan and Ahmed?
Uh,
See, they are in rest position here. Okay, but as soon as it was touched, the the gold leaf strips are running away from each other. Yes, Arhan. Yes, Arhan, are you there? Ahmed,
yes,
do
sir.
tell me, do tell me why the two gold leaf strips are repelling each other?
Sir, because of the continuous change of the neutrons and electrons.
No, no, no. Notice the charges in the two strips here. This one also has got positive charges, and this one also is having positive charges. Okay,
Yes.
and we know that positive charges repel each other. Hence, the two strips started to repel each other.
Oh,
Okay.
okay, sir. Got it.
Okay. One more question to you guys: why we have taken a cork to seal the container here, and why not a metal?
Sir, because cork is a good conduction of
Good conductor? It's
no,
a
not
bad
good.
conductor.
Yes.
Yeah.
Uh,
Arhan,
sir,
are you there? Yes, Ahmed.
maybe sir, is it because so it can pass through the positive charges or
If we would have taken a metal object to cover the container, then what will happen? There will be disturbance in the transfer of charge. The charge will be acquired by that metal object as well. In place of cork, if you have taken a metal object to cover the container, the charge would transfer to that metal object also. But we don't want that to happen, right?
yes, sir.
Okay, now let's see further. Ahmed, are you there or not?
Sir, I am here. I
Oh,
was
I mean,
answering.
Arhan is not saying anything. Okay, so let's move ahead. See,
We observe that as soon as the positively charged glass rod is brought in contact with the neutral metal disc, the gold leaves diverge due to the presence of similar positive charges on them. Now, remove the glass rod. We notice that the leaves
now
still
we
remain
have removed
diverged.
the
This shows
rod which
that
was in contact to
electroscope
it.
is charged.
Okay, okay, guys. So now we have removed that positively charged rod from its contact, but still the body is still the metal. This gold strip still it is having positive charge. Okay,
Yes, sir.
because
By
it has become
conduction.
positively charged.
Now, touch the electroscope with your hand. What do you notice?
No,
We
here
find
what just happened?
that the gold
Once you touched it, what just happened here? We observed here that the object lost its positive charge. Why? Because all the positive charge from this object was transferred to the ground. Okay, right.
Okay, sir.
Okay, so their conduction happened.
leaves collapse. This indicates that electroscope is
Okay,
discharged. What happens to the charges? As you touch the metal disc, the electrons from the earth travels through the body and pass from the hand to the metal disc and neutralize the positive charges. We can also say that earthing takes place as we touch the electroscope. An electroscope can be negatively charged when a negatively charged ebonite rod is
Right.
brought in.
So you guys see here what just happened. When we touch the metal cap here, the electrons from the ground, we must be standing on some ground. So the electrons from the ground started to reach this gold strip here via our body. Okay. And then what happened? The number of protons and electrons in this became equal. Hence, the gold strips return back to its normal position. Right? They are no longer repelling each other because the number of protons and electrons then became same in it. Okay, so we can repeat the same activity with bringing a negatively charged object close to it by touching the negatively charged ebonite rod to it as well. Okay, and in that as well, you will observe the two gold strips will repel each other. And okay, so we can repeat the same experiment using a negatively charged rod as well. All right.
Excuse me, sir.
Yes, Rahan.
How will we know that what material is negatively charged and what material is positively charged?
Okay. By convention, when two objects were rubbed against each other in the experiments, we derived that the object is positively and negatively charged. Okay. So that has been
Okay, sir.
experimented and